Hey fellas, I'm Manuel Escamillas, and I'm gonna discuss about peripheral interface. The first of is von Neumann computer model. A von Neumann computer model is an architectural design for any electronic digital computer. It has input, which you feed the computer information. Output, which you process information is released. Memory, which holds the current operations and stores the data. CPU, or the central processing unit, which performs the basic operations of the system. The next is the part of a computer. Hardware. It is the physical device and circuitry of the computer. Software. It is the intangible parts of the computer. It is the programs written for the computer. Firmware is the term given to the programs stored in ROMs or in programmable devices which permanently keep their stored information. Peripheral interface categories. The first one is analog or digital interface. To interface two peripherals, one of them is digital and the other one is analog. We have to add analog to digital converter, or ADC, and digital to analog converter, or DAC. The second is synchronized and asynchronous interface. Two important categories of interface are used to connect peripherals. The first one is synchronized interface, which depends on the clock, and the second one is asynchronous, which can be accomplished without clock. To interface these peripherals together, we need a shaking adapter, which regulates the data exchange between them. The last one is serial parallel interface. To interface two peripherals, one of them is parallel and the second one is serial, we have to use parallelizing and serializing stage to connect both of them. The parallelizing stage converts the serial pulses into parallel data, while the serializing stage converts the parallel data into serial pulses. Bus system classification. According to function, data bus, control bus, and others bus. According to location, internal or direct. Example of this is ISA, EISA, PCI, AGP, USB, SCSI, IDE, and SATA. Another one, according to location, external or indirect. Example of this is GVIB, CAMAC, and CAN. Bus system classification according to purpose. The first is general purpose, the second one is special purpose. The bus is not only a cable connection but also hardware, bus architecture, protocol, software, and bus controller. Now we're down to important definitions. The PNP, short for plug and play, is an ability of a computer to detect and configure a new piece of hardware automatically without the requirements of the user to physically configure the hardware device with jumpers or dip switches. For plug and play, to offer it properly on IBM compatible computers, the user must have the following. The first is BIOS supporting plug and play. Second is operating system supporting PNP. The last one is peripheral with PNP support. But today, all new computers have PNP capabilities. Computers running Microsoft Windows no longer support non-PNP devices. Another one of important definitions, throughput. Throughput, or baud rate or speed, also known as communication speed. Throughput is a numerical value used to illustrate the total amount of data transferred or being transferred through the computer or device at a given time. This number is commonly represented in bits per second or BPS, or bytes per second or capital VPS. Important definitions. Propriety. Term used to describe a product that is only compatible with a specific type of hardware, software, computer, or manufacturer. When referring to computer hardware, it is recommended that you do not choose a proprietary device as it reduces compatibility and generally the capability of upgrading that product in the future. Now we're down to buses. The first bus is ISA bus. Introduced by IBM, ISA or Industry Standard Architecture was originally an 8-bit bus that was later expanded to 16-bit bus in 1984. When this bus was originally released, it was a proprietary bus, which allowed only IBM to create peripherals and actual interface. However, in the early 1980s, other manufacturers were creating the bus. ISA or EISA bus, short for Extended Industry Standard Architecture. ISA was announced September of 1988 ASA is a computer bus designed by 9 competitors to compete with IBM's MCE bus. These competitors were AST Research, Compaq, Epson, Hewlett-Packard, NEC, Olivetti, Tandy, Weiss, and Senate Data Systems. The ISO bus provided 32-bit slots at an 8.33 MHz cycle rate for the use with 386DX or higher processors. In addition, the ISO can accommodate a 16-bit ISO card in the first row. Unfortunately, while the ISO bus is backwards compatible and is not a proprietary bus, the ISO was never became widely used and is no longer found in computers today. PCI bus, introduced by Intel in 1992, revised in 1993 to version 2.0, and later revised in 1995 to version 2.1. PCI is short for peripheral component interconnect and is a 32-bit computer bus that is also available as a 64-bit bus today. The PCI bus is the most commonly used and found bus in computers today. PCI-X is a high-performance bus that is designed to meet the increased I/O demands of technologies such as Fiber Channel, Gigabit Ethernet, and Ultra 3 SCSI. PCI-X capabilities include up to 133 MHz bus speed, 64-bit bandwidth, 1 GB per second throughput, more efficient bus operations for easier interface. Split transactions allows an indicator device to make only one data request and relinquish the bus, instead of constantly needing to fall the bus for a response. Byte count that enables indicator to specify in advance the specific number of bytes requested, eliminating the inefficiency of speculative prefetches. And it is backward compatibility. The PCI slots. Various PCI slots from top to bottom. PCI Express X4, Express X16, Express X1, Express X16, and conventional PCI, which is 32-bit. AGP bus. Introduced by Intel in 1997, AGP or Advanced Graphic Port is a 32-bit bus designed for high demands of 3D graphics. AGP has a direct line to the computer's memory which allows 3D elements to be stored in the system memory instead of a video memory. For AGP to work in a computer must have the AGP slot, which comes with the most Pentium 2 and Pentium 3 machines. The computer also needs to be running Windows 95, OSR 2.1, Windows 98, Windows 98 SC, Windows 2000, Windows ME, or higher. Buses, serial ATA or SATA. First generation SATA devices often operated at best a little faster than parallel ATA 133 devices. Subsequently, a 3 gigabits per second signaling rate was added to the physical layer, effectively doubling maximum data throughput from 150 MB per second to 300 MB per second. For mechanical hard drives, SATA 3 gigabits per second transfer rate is expected to satisfy drive throughput requirements for some time, as the fastest mechanical drives barely saturate a SATA 1.5 gigabits per second link. SATA revision 3.0 or the SATA 6 GB per second. Serial ATA International Organization presented the draft specification of SATA 6 gigabit per second physical layer in July 2008 and ratified its physical layer specification on August 18, 2008. The full 3.0 standard, peak throughput about 600 MB per second, was released on May 27, 2009. USB or Universal Serial Bus. It's a new external bus developed by Intel, Compaq, DEC, IBM, Microsoft, NEC, and Northern Telecom, and released to the public in 1996 with the Intel 430HX Triton 2 motherboard. USB has the capability of transferring 12 Mbps, supporting up to 127 devices, and only utilizing one IRQ. For PC computers to take advantage of USB, the user must be running Windows 95 OSR 2, Windows 98, or Windows 2000. Linux users also have the capability of running USB with the proper support drivers installed. USB cables are hot swappable, which allows users to connect and disconnect the cable while the computer is on without any physical damage to the computer. Versions of USB. The first one is USB 1.0. The original release of USB supports 127 devices transferring 12 Mbps. USB 1.1, also known as full speed as USB. It is similar to the original release of USB, however minor modifications for the hardware and specifications. This version of USB still only supports a rate of 12 Mbps. USB 2.0, also known as high-speed USB, was developed by Compaq, Hewlett, Packard, Intel, Lucent, Microsoft, NEC, and Philips, and was introduced in 2001. High-speed USB is capable of supporting a transfer rate of up to 480 Mbps and is backwards compatible, meaning it is capable of supporting USB 1.0 and 1.1 devices and cables. USB 3.0. USB 3.0 was released in November 2008. The standard specifies a maximum transmission speed of 5 gigabits per second or 625 MB per second, which is more than 10 times as fast as USB 2.0, which is 480 megabits per second or 60 megabytes per second. Although this speed is typically only achieved using powerful professional grade or developmental equipment. USB 3.0 reduces the time required for data transmission. It reduces power consumption and is backward compatible with USB 2.0. USB architecture. USB architecture has host, hub, and device or node. The host contains one host per system. Typically, the PC in standard USB topology can be any device in OTG. The hub provides connecting ports, power, and terminations. The device, which is the peripheral application. USB specifications: a unique connector, hub topology, auto detection and configuration. Low power. It is high performance, supports up to 127 external devices, provides power. Backwards compatibility: USB 1.1, 12 Mbps, USB 2.0, which is 480 megabits per second. USB topology. A USB has a maximum cable length up to 30 meters. Maximum of 5 non-root hubs. Only a portion is allowed in tier 7. Maximum of 6 segments. Hub at center of each star. Each segment is 5 meter max. Tiered star. USB devices. First one is hub. Simplifies USB connectivity, detect and attach, and the touch. Functions. USB devices that transmit or receive data. Firewire. It is created by Apple. Its speed is 400 Mbps, and the later versions has 800 Mbps for 1394 bytes. Can send more than a CD every 10 seconds. It is plug and play. Support up to 63 devices. Provides power. Provides digital audio, video, external hard drives. The original firewire was faster than USB when it came out. Transfer rates up to 400 Mbps. The maximum distance between devices is 4.5 meters of cable length. Eventually, Firewire 800 replaced USB 2.0 very easily. Firewire 800 had a transfer rate of 800 megabits per second. The maximum distance of cable length between devices is 100 meters. Now we're gonna discuss the advantages and disadvantages of Firewire versus USB. The USB 1.1 is 12 Mbps, while the Firewire 400 is 400 Mbps. Then the later version of USB, which is USB 2.0, has a speed of 480 Mbps, while Firewire 800 has a rate up to 800 Mbps. And the later part of USB, which is USB 3.0, has a maximum capacity transfer rate of 5 gigabits per second. Bluetooth. Introduction to Bluetooth. It is a proprietary open wireless technology standard for exchanging data over short distances, using shortwave link radio transmissions in ISM band from 2400 to 2480 MHz from fixed and mobile devices, creating personal area networks or FANs with high levels of security. Created by telecoms vendor Ericsson in 1994. It was originally conceived as a wireless alternative to RS-232 data cables. It can connect several devices, overcoming problems of synchronization. Bluetooth is managed by Bluetooth Special Interest Group, which has more than 15,000 member companies in the areas of telecommunication, computing, networking, and consumer electronics. The SIG oversees the development of the specification, manages the qualification program, and protects the trademarks. To be marketed as a Bluetooth device, it must be qualified to standards defined by the ISG. A network of licenses is required to implement the technology and are only licensed to those qualifying devices. That's the protocol. Wheels often may be regarded as proprietary. Here are the instruments which use Bluetooth technology. RFID. Introduction to RFID or radio frequency identification. It is use of a wireless non-contact system that uses radio frequency electromagnetic fields to transfer data from a tag attached to an object for the purpose of automatic identification and tracking. These are the instruments which use RFID, which is mostly tags. NFC based on RFID. Introduction. NFC or Near Field Communication is a set of standards for smartphones and similar devices to establish radio communication with each other by touching them together or bringing them into close proximity, usually no more than a few centimeters. Present and anticipated applications include contactless transactions, data exchange, and simplified setup of more complex communications such as Wi-Fi. And the instrument uses NFC. CAN, Controller Area Network, or CAN bus, is a vehicle bus standard designed to allow microcontrollers and devices to communicate with each other within a vehicle without a host computer. CAN is a serial bus protocol to connect individual systems and sensors as an alternative to conventional multi-wire looms. It allows automotive components to communicate on a single or dual-wire networked data bus up to 1 megabits per second. The engineering software. Example of this is MATLAB, LabVIEW, HPV, IDL, C++, Java, Linux, LaTeX, and Qt. And thank you very much for listening.